Hello and welcome to this new video about algorithmics. In today's video, I'm going to be describing the data structures needed for algorithmic interviews. So this is like a very easy and simple introduction to what's the needed data structures for a coding interview. And so these are the basics. I'm going to try to be the simplest that I can, and if you can understand these, so you can basically follow with me in the videos that I'm making. So the first thing that you should understand are variables. So variables are a piece of memory that's where you can store a piece of information. So a variable has a name, for example a, and it has a value. And there are two kinds of variables that you can use. You can have either a constant or a variable that's its value can change with time. So a constant is fixed, so the moment you're gonna initiate it, it's not gonna change during the code. So for example, in order to indicate that in JavaScript, for example, you can say const, but other languages use different syntax, but it's the same principle. So the moment I say const a equals 1, a will never change its value. It will always be 1 during the code. Let's just create another variable b, and I'm going to initiate it with 2. And I'm going to say it's a let. And this in JavaScript, but in other languages you can use other syntax. It's going to indicate that it's a variable that can change its value. So during the code, I can say, for example, b equals to 3. So I change the value. Or I can, for example, b plus plus. Or I can say b equals to b plus 4. So you get the idea. Whenever you need a variable that you're going to keep changing during the code, then you need to create this kind of variable. So so the variables are important and to basically manipulate data. But the moment you're gonna start having like a recognized like a number of variables, then you cannot just put them in variables. You're gonna need to start using more data structures that are fit for the task. For example, imagine you are getting like an n elements. So you cannot have just like n variable, because that's just basically unfeasible. So what you're gonna do, basically you're gonna need to use arrays or linked lists. Array and linked list, they are like a data structure that has n elements. So let's start with arrays. So I'm gonna like draw an array. So every element has a value. For example, e, and every element has a value and also has an index. So here it starts with 0, the first element. Second element is 1, 2, and we keep increasing by 1 till n minus 1, knowing that n is the length of the array. And so every element here, for example, if it has the index I, we can access the elements, the value of the elements, by saying, for example, if this is x, the name of the array, we can say x of I, and we get the value. We can also change the value in the index I by just like saying, for example, x of I equals 2, and then we're gonna put here 2. So what is the advantages of using arrays? It's the easy access of elements when we know the index. So if we know the index of any element, we can just access immediately, and that's an O of 1 complexity, which means a direct access. However, it becomes a little bit more complicated the moment we need to insert or delete an element from an array. So let's just say, for example, we need to delete the second element in here, b. So what's gonna happen basically behind the scenes? So if we wanna delete this, it basically means that we're gonna like shift every single element on its right to the left. So we're gonna put C here, and then we put the element here on the left side, and we keep doing that till the end. And at the end, we decrease the length of the array by 1. So let's give an example. If we have 1, 2, and 3, if we delete 1, it means we're gonna like basically put a 2 here and a 3 here, and then this is gone, and the length is gonna become from 3 is gonna become 2. And that's it. So basically the complexity of removing an element is an O of n, because the worst case is deleting the first element, which means that we need to shift every single element on the right side to the left, which is an n shift. However, if we want to insert an element on an index I, it means that, for example, if we have this array 1, 2, and 3, and we want to insert here a 4, it means, so let's just say there are more elements. It means we're gonna shift every single element on its right, the right side. So it's gonna be 1, 4, but before we put 4 here, we start shifting elements one by one. So this one should go here, and this one should go here, and we keep going. And that's basically also an O of n for an insertion. So these are the disadvantages of an array. So the insertion and deletion are an O of n, which is complex, but the access is, or modification of an element, is instant. And this brings us to a linked list. So the linked list acts kind of like the same as an array. However, it's like the representation is by node. So for example, if you have 3 elements like we had before, it's going to be a node, first node, which is the root. It's going to have the value 1, which is pointing to the second node, and third node, and the last one is going to point to null, which means nothing. And every element has an index as well, the same as the array. So in this example, if we want to access to this element by its index, which is 2, we cannot just access immediately. We have to start from the beginning, because we only have access to the first one. So from the first one, we can access the second one, and from the second one, we can access the third one, and then this is the index we are interested in, and then we can have the value, which means in order to get the value from a linked list, it's a complexity of O of n, which is like not great. It's worse than the array. However, the advantage is when we want to insert or delete an element from the linked list. This is when the linked list shines. So basically, imagine we want to insert an element here between 1 and 2. So this is how it's going to happen. So let's just say we give it a value 6. And we want it to be here between 1 and 2. So we point 6 to 2 here. And then we break this link, and we just point 1 to 6. And that's it. So, and then we're going to have a list of four elements. And it's going to start by 1, 6, 2, and 3. So the insertion is kind of like fast and almost instant, because we only manipulate pointers. And also the deleting is quite fast. So imagine we want to delete this too. So how are we going to do that? So all we need to do is just find the previous element of this node and point it to the next element, which means we are going to break this link. And that's it, basically. And the list becomes 1 and 2, and this is gone. So the deleting or inserting an element in an array is quite fast, but accessing an element by its index is quite pricey. So you have like trade-offs, and you have to choose which one you're gonna use. So basically, if you're gonna insert a lot of data in your data structure, you have to use linked lists. But if you're gonna if you're gonna insert not much, like just a little, but access a lot the data, then maybe you should consider using an array. Now let's move to a hash map. A hash map is a data structure that is kind of like a dictionary, which means like a key value. So every element has a key and has a value, and we can represent it like this. So every element has a key and also has a value. So let's just say we insert an element with the key A and its value is 3, and B and 4. And here we keep inserting, and let's just say here we have C and its value is 10. So imagine we have the key and we want to find the value of the key. That's kind of instant, because let's just say we have C and we want to get 10. So basically we just go and we say map gets me the value that has the key C, and we access 10 immediately. So the access is quite fast. Also the insertion is quite fast. So yeah, so basically whenever you want to keep a data structure of a like key value, you should consider a map, and that's very used in algorithmics. Imagine, for example, an example of a case use case is when we want to, like, for every element we want to count how many occurrences it did happen. So we can say, for example, A occurred 3 times, B occurred 4 times, and every single time we see the element, we just come and we find it by key and we increase its value. We find another B, we increase its value. Yeah, so that's basically hash maps. Hash maps are very widely used in algorithmics, and I think you should consider them anytime the opportunity comes, and we're gonna use them a lot in the videos that I'm making. Now the last one is a set. A set is basically like a hash map, but or also a list or whatever. It allows us to have non-duplicated values. So imagine that this is the where we store elements, which is a set. So imagine we insert a 2. So the 2 is not was not there before, so we just add it. Now let's insert a 3, let's insert a 4, and now let's insert again a 2. So if you want to insert a 2, it's already there, so nothing changes. If you want to insert another 3, nothing changes. So basically, the most important thing, you cannot have duplicated values. So everything is not duplicated. And also the access and insertion is, the price for insertion and access is quite fast. It's like a hash map, because beneath the implementation is actually a set, is a map with the constraints of non-duplicated values. Yes. So a use case for algorithmics is if you want to keep a track of the element that you saw before, you just basically use a set. So anytime you see a new element, you ask the set, do you have this element? If no, you just insert it. If you have it, if the set has the element, you basically know that you saw it before. Yeah, so of course these are the basic things that you should understand, but also of course there are more stuff that you should consider in order to master coding interviews or algorithmics questions. So you should understand how to use recursion. We're gonna have examples. I already have examples of videos that I use recursion. Also, you should understand how to use trees. So trees are widely used, especially with problems with graphs. And also you should know how to use a heap. And the heap, there are 2 kinds of heaps. widely used, the min heap and the max heap. But this is for another episode where I can dive in more more deeply. Or basically we're gonna see them through exercises where we can see truly why we need this. But for the moment, if you are just starting to do algorithmics, if you don't understand these basics, I don't think you can move any further. You should try to understand what is each and what's the advantages of each and why you choose one and not the other, so you can basically make decisions while you are making algorithms. Yeah, so thank you for watching. If you did like the video, please give me a thumbs up, and also a subscribe. That helps a lot my channel to grow, and also YouTube to promote it to other people who likes this content. Thank you so much, and I'll see you in the next one.